Hi, welcome to Sequences and Series Part 3. So now that we've taken an introductory look at two of our formulas, we're going to actually put them into practice with this sample question. So let's go ahead and read it. It says, what is the sum of the first 16 terms in the sequence above? Well, first and foremost, we have to figure out what type of sequence we're dealing with. So if we take a look, as we go from 8 to 14 to 20 to 26, do we see something in common with the difference between each of those terms? If you said that we do, and that we're adding by 6 each time, then you're in great shape. Since we're adding by the same amount between every term in our sequence, that lets us know we're dealing with what's called an arithmetic sequence. And if you have questions on what that means, feel free to watch Sequences in Series Part 2, in which we introduce arithmetic sequences and series and talk about these formulas that we see already noted on the top left of the board. Now that we have those formulas in our pocket, we're going to see if we can put them into practice to answer this question. So for right now, let's just get a list of the variables from those formulas that we know. So in the question, they want to know what is the sum. So off the bat, we know that we're looking for S. We're looking for the sum of this sequence. And since they say the sum of the first 16 terms, that means our value for n will be 16. So I'm just going to list some of the values that we know over to the left, and we'll work with them as needed. So right now we know that n equals 16 for this problem. We also know, based on the sequence itself, that if we start just by looking at that first term, do you remember what variable represents the first term in the sequence? If you said a sub 1, you're correct. So whenever we see a1, what they're asking us to plug in is just the first term in the sequence, which in this case is 8. So that means that a sub 1 equals 8 for this sequence. Now a variable that we do know a value for, but that is not listed, and this is one of the subtleties that sometimes can make sequence and series questions very difficult. We do know the value of d, the difference between each term. They don't tell us that value outright in this question. They don't say d equals a certain value. But if we look at that difference between any two terms, the difference, if you were to do 26 minus 20, or 20 minus 14, or 14 minus 8, either way, the difference is 6 every time. So we do know a value for d. In this case, d equals 6. That's the difference between our terms in our sequence. And now we have all the components necessary to solve for the sum. If we notice in our formula for sum, it requires us to know a sub n, which in this case would be the 16th term, a sub 16. But we don't have that value yet. So this is a slightly advanced question because we are going to have to plug in our first formula to solve for that 16th term, and then plug that value into our formula for sum to calculate our final answer. So let's take a look at how this looks. Starting with the formula on top to find that 16th term, we plug in 8 for a sub 1, we plug in 16 for n, and we plug in 6 for d. So this formula for our 16th term will be 8 plus, in parentheses, 16 minus 1 times 6. And to do the math on that, 16 minus 1 gives us 15. And 15 times 6, can anyone try that in their heads? So if you said 90, that's correct. A good way to break up terms, just as a little multiplication tip, if you're multiplying a number like 15 times 6, you can break it up. 15, you can first work with the tens column. You multiply 10 times 6, which is 60. And then you work with the ones column. You multiply 5 times 6, which is 30, and put them together. 60 and 30 would give us 90. So we have 8 plus 90, and that gives us 98 for that 16th term. Now we have all the values necessary in order to solve for the sum. So in this one, for s sub 16, we're going to plug in the values that we have listed over here. And now we have this new value to plug in for the 16th term. So we have n is 16, so we start with 16 over 2, times, the first term is 8, the 16th term is 98, And we take our time and go ahead and do the math on this. 16 divided by 2 gives us 8. 8 plus 98 gives us 106. And if we multiply those together using that same multiplication strategy just mentioned, we can do 8 times 100, which would be 800. That's something usually a little bit more comfortable for us to do in our heads than 8 times 106 altogether. If we do 8 times 100, that's 800. And then 8 times 6, that's 48. So if we put them together, it gives us a total value of 848 as the sum of the first 16 terms in this sequence. Now you could also, for any sequence question, just take your calculator, if you're allowed to use a calculator on your test in your class, and you can do 8 plus 14 plus 20 plus 26, so on and so forth, and keep typing in plus, 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 and let your calculator do some of this work for you. The nice part about knowing these formulas and having them in place ready to go whenever you need them is depending on what term you're being asked for. If you're asked for the second or third or fourth term in a sequence, it's not bad to write everything out because that's a relatively short sequence that you'd have to write out. But if you're being asked for the 112th term in a sequence, you probably don't want to write out 112 terms, nor do you want to enter 112 terms into your calculator to try to sum them together. And that's really where our equations and formulas come into play and can be really advantageous for us to make for less work when calculating the answer to some of these sequence and series questions. If you'd like to learn more, please feel free to visit our website, www.sandersontestprep.com. The link is in the description below. Thanks.